Hey there, party people. Welcome back to our channel, How They Made. Today, we're going behind the scenes to explore the fascinating process of making balloons. In this video, we dive into the mesmerizing world of balloon manufacturing. From the initial stages of raw material selection to the final inflated product, join us on a journey through the intricate process of balloon production. Get ready to be amazed as we uncover the secrets behind the creation of these fun and versatile objects that bring joy to people of all ages. Subscribe now to join our community and stay up to date with all the latest adventures, discoveries, and wonders of the world. The history of balloons dates back thousands of years, with early civilizations using materials like animal bladders and intestines to create rudimentary inflatable objects. These early balloons were often used in religious ceremonies, rituals, and as children's toys. Rubber balloons were eventually invented in the 19th century, but latex gradually took their place. There was a benefit in utilizing latex as a material because of its extreme elasticity, which allows it to stretch up to 7 or 8 times its original size. Raw natural rubber resembles milk in appearance. It is a thick white or yellowish liquid. Some plants, especially the Brazilian native Hevea tree, secrete a substance called latex. Nowadays, rubber from natural rubber plantations in Malaysia and Africa is the most important supply. Rubber producers need to harvest these trees for their raw materials. Expert laborers, referred to as tappers, use specialized tapping knives to create cuts in the rubber tree's bark. The milky white latex sap can now flow from these incisions into collection cups that are attached to the trees. Over several hours, the milk-like latex sap slowly fills the collection cups. Tappers visit the trees periodically to collect the latex, typically every 1 to 3 days, depending on factors like tree health and climate. After being collected, the latex is treated to stop it from coagulating and becoming inappropriate for use in other processes. As a preservative, ammonia is frequently added to latex to keep it fluid throughout storage and transit. The latex is blended with various additives to enhance its performance in balloon manufacturing. Antioxidants aid in preventing the latex from deteriorating from exposure to light and air. In order to increase the flexibility and durability of polymer chains by encouraging cross-linking during curing, vulcanizing chemicals are used. The latex undergoes a concentration process to remove excess water and increase the concentration of rubber particles. This can be done by evaporating the latex, which involves applying heat to remove water, or centrifuging the latex, which involves spinning it quickly to separate the solids from the liquids. The latex is then moved using tanker trucks or specialized containers from production sites to balloon manufacturing factories. Extreme temperatures or mechanical damage are kept away during shipment to avoid compromising the latex's quality. To avoid lumps, the latex is combined with dye at the manufacturer and filtered through cheesecloth. It is rotated for 15 hours by agitators at the bottom of the tank. This disperses the color and maintains the pliable nature of the latex, which would otherwise solidify. This factory produces balloons in as many as 53 different colors. The molds used to shape round balloons in a factory look like neatly arranged upright baby rattles traveling on a tray. They might be arranged in a grid with, let's say, 3 rows of 11 molds for each. This mold tray will roll from one station to the next, some of which have fixtures specifically designed to flip the tray over so it can be dipped into different chemicals. Before all of this, though, a system of rollers cleans the balloon forms or molds by spraying them with hot water. After that, these forms are turned over and submerged in a coagulant tank. The coagulant also contains an electrochemical charge. When the balloon forms with a coagulant interact with the tank containing the colored latex, they attract the latex solution, resulting in a thin, uniform coating over the balloon molds. The longer the forms are left in the tank, the thicker the coating that sticks to them. The forms are only submerged in latex for a short amount of time, since balloons require a very thin covering. In order to attain an even thin coating and prevent air bubbles from being trapped, the forms must be entered and removed at precisely regulated speeds. After that, a conveyor moves the balloon forms in the direction of spiraling brushes. These brushes create lips by rolling up the balloon's bottoms. It is now simpler for people to hold the balloons and inflate them thanks to these grips. After that, the balloon shapes are submerged in a heated water bath. This is a crucial step because it removes the protein that causes latex allergy from the latex and cleans it. The latex is rubberized via vulcanization, which is likewise triggered by the hot water. Charles Goodyear made the entire accidental discovery of this method, which completely changed the rubber business. It greatly improves rubber's elasticity and toughness. Raw rubber is sticky, somewhat soft, and prone to degradation under a variety of circumstances until it is vulcanized. After vulcanization, rubber becomes more resilient and can withstand greater stress, making it suitable for a wide range of applications. Removing the balloons from the molds is the next step. The forms are dipped into a solution of talcum powder and water to facilitate the process. This will enable them to be removed from the form without any problems. It's finally time to remove the rubber coverings from the forms. Air jets nourish the balloons with air as they go through this equipment. Rollers at the top grasp the balloons as they begin to emerge from the form and roll them away from the forms as they fill with air. After that, the devoid balloons collapse onto a conveyor belt. A worker receives them, puts them onto an industrial washing machine, and adds a cleaning solution after that. The machine heats to 70 degrees Celsius. This process not only cleans the balloons, but also completes the vulcanization of the latex. To make sure they can sustain inflation without bursting, balloons are put through pressure testing. This is blowing up balloons to their maximum volume and then putting them under certain pressures for a set amount of time. In order to satisfy consumer expectations, quality control techniques also involve evaluating color similarity between batches. Strict control over the balloon manufacturing environment is necessary to maintain high standards of quality throughout the production process. The temperature of the latex tank, the ovens, the dryers, and other factors are all monitored and managed by computer-based equipment. The method requires that the latex and other chemicals be precisely prepared for desired qualities and kept in good condition. For instance, the latex needs to dry quickly and have a specific stickiness. Devices that keep the latex moving in the tanks where it is kept are necessary to prevent components from settling and to prevent skin from forming. Once quality control inspections are passed, balloons are arranged and wrapped in accordance with client specifications. One packaging method is to bundle balloons together or wrap each one individually. To preserve their integrity, packaged balloons are kept in climate-controlled storage facilities. Careful handling during transportation prevents damage and deformation. And there you have it, folks, the incredible journey of how balloons are made, from raw materials to the finished product. We hope you enjoyed this behind-the-scenes look at one of the most beloved party essentials. Don't forget to hit that like button and subscribe for more fascinating content. Until next time, keep on celebrating.